Hello everyone, I am Surekha. I am working as an assistant professor at Siddharth Group of Institutions, Puttur. So now I am going to discuss about artificial neural networks. The artificial neural network is an efficient information processing system. So this processes the user information and it produces exact results to the given problems. So which resembles the characteristics of biological neural network. So in our brains, we have huge number of neurons. So in this artificial neural network, so it contains a large number of highly interconnected processing elements. So that elements are called as nodes or neurons. Sometimes the nodes also called as units. So this each neuron is connected with other by connection link. So and each connection link is associated with weights and which contains information about the input signal. So in our brains we have neurons. So each and every neuron connects with axons. But in this artificial intelligence, each and every neuron connects with some interconnections or connection links, and that connection link transmits input signal to the network with respective weights. So and this artificial neural network have ability to learn, recall and generalize training patterns or information similar to our brains. So the artificial neural network processing elements called neurons or artificial neurons. So artificial neural networks provides activation functions. So activation functions are the special functions which are introduced by the artificial neural networks. So if we use artificial activation functions while processing the information, so it boosts up the information processing and it provides exact results compared to uh, processing of information. So this activation signal of neuron is transmitted to other neurons. And a neuron can send only one signal at a time, so which can be transmitted to several neurons. Consider this example. So this figure shows two input signals, x1 and x2. So lowercase x1, x2, these two are the input signals, and this uppercase x1, x2 are input neurons. This x1, x2 transmit the input signals with respective weights W1 and W2 to the network to produce respective output. So here this uppercase Y represents the net output value, and this y is the actual output. So the net input is calculated as y input equals to, so the sum of input with weight. So here we are using two input vectors, right? X1 and X2. X1 with weight W1 plus X2 with weight W2. So this is the formula to calculate the net input value. So here X1 and X2 are the activation of the input neurons X1 and X2. So this is the output of the input signals. So the output of the output neuron Y can be obtained by applying this method to the over net input values. See, this is the function to represent the actual output. So y equals to f of net input vector. So f of y. So this is the function to be applied over the net input is called activation function. So here we are using linear activation function. So y equals to for all y input vectors. So this net input calculation is similar to the calculation of output of a pure linear straight line equation y equals to mx. Because of here we are using a linear function, a linear activation function. See, this is the example figure. This neural net for pure linear equation. So here we are transmitting input signals x to the network to form respective output y with weight m. So obviously it produces the respective output as mx because of we are transmitting x input with m weight. So the output is the combination of input with weight. This is the method to calculate actual output value. So this is a small example for artificial neural network. Thank you.